So blockchain is an incredibly big topic everywhere around the globe right now, and it's become one of these funny words in English that doesn't even require an article. So you don't talk about a blockchain or the blockchain. So just as you asked, we talk about blockchain, the capital B, and the only other word that I know that gets this treatment is the word God.
This is Emin Gün Sirer, a professor at Cornell University who's currently visiting EPFL. Sirer is one of the leading world experts in research on blockchain. But what is blockchain?
It's essentially a simple data structure where you have interlinked blocks that collect some data into a format that is immutable and totally ordered. So essentially, it's a set of nodes that agree on a particular sequence of transactions.
So basically, blockchain is just a record of information ordered in a chronological manner.
You might think that this is really simple, which it is, but it's also foundational.
In fact, ordering events in a chronological order that everyone agrees on has been a long-standing open problem in distributed computing, as we discussed it in a previous video.
Now suddenly, we have the ability to execute some program, some computation or some business process, whatever it might be, at a large number of nodes in tandem, in sync, and come to the same result and same conclusion. And this is then the foundational building block for a lot of exciting applications.
Now, just to give you an idea of how influential this may be, it's useful to first ponder what had to be done before the advent of blockchain.
Before blockchains, the way people actually managed devices or managed data is they kept the data themselves and interacted with other people who kept a copy of the data. So you and I, for example, if we were to trade stocks, I would make a mark in my system. I'd send a message to you saying I would like to trade X for Y. You would make a mark on your system and you would say okay to me. And at the end of the day, we have some marks on our respective systems.
Typically, when signing a contract, you would print 2 copies of it and give 1 copy to each of the parties involved. Of course, banks that deal with millions of contracts cannot have such a slow procedure, so they designed a digitized version of it.
This sounds like an okay idea. It sounds like we get to the same issue. The two of us engaged in some transaction and we have some record of what happened, but that's not sufficient, it turns out.
Why so?
Well, because my markings might be different than yours for beginners. So what does that mean? Well, it means that I might disagree with you on small details. For whatever reason, due to software faults or different logic, we might have recorded slightly different things. And suddenly we might find ourselves in very different worlds. That is, I believe I read this and transacted that way. You believe that you gave me some other data and you disagree on how we transacted. One of these things can happen. So now we have a disagreement.
And disagreements are a major part of the business of banks.
A lot of financial technology companies have enormous resources dedicated to reconciliation, which is the process of making these machines actually reconcile their records. What I think of as trade X is trade Y on your system, but they are the same trade, aren't they? This is the question they ask at the end of each day.
And reconciliation is both extremely tedious, hugely time-consuming, and immensely costly.
So when I was a kid, I had a cousin who worked at a bank, and I'm sure there are many people listening who have relatives who work at banks and so forth. And there, at the end of the day, if there's any discrepancy in the books, even if it's 1 cent, she could not come home. And the reason for this is actually quite simple. That 1 cent discrepancy could be stemming from $1 million discrepancy that is being offset by another $1 million and 1 cent discrepancy. And in the end, you only see it as 1 cent, but it might be hiding a $2 million problem of some kind. So they had to make sure that the books were actually proper.
Tiny mistakes can have major impacts when dealing with such amounts of money.
And so it's essential that we reconcile, and it's non-trivial to reconcile. I recently visited Bank of America, and this is as big, as wide as a New York City block, so imagine how wide that is. It's fairly big. It's about 100 meters or so by 100 meters. And 2 floors of Bank of America is dedicated to reconciliation. So it's a lot of human power just for the simple task of making sure that what I think of as something is the same as what you think of as something else.
Now, this is just due to mistakes, either human-made mistakes or computational glitches. But evidently, classical contracting poses many more problems.
And the second problem is in more contentious settings, where I don't fully trust you, and I can't fully audit you, and you tend to be, let's say, a bit more aggressive and maybe more profit-oriented, or think that you can get away with it, you can actually lie to me about what happened. So this is really, really problematic, where I will engage in transactions with you, but then at the end of the day, when I come to try to hold you accountable, you say, well, that never happened. So if you hold your own data, you've got your own Oracle database or whatever, you can rewrite the past any which way you like. And I have no recourse when you were to try to do this to me. And in business, this can lead to real big problems.
Of course, there may be big problems afterwards. But as well, given that contracting heavily relies on trust, this also makes it harder to agree on a contract beforehand, which evidently hinders business opportunities.
In many business settings, maybe this won't happen because the participants are mostly honest, 99.99% of the time. But then the remaining percent of the time, they can cause great ripple effects.
But that's not all.
And then, of course, there's the final problem, which is you as an institution, you are honest, but there might be insider attacks. There might be elements you don't control about the database. There might be software errors that cause your system to diverge from mine. And so that will create also all sorts of issues.
Let's give an example.
Every defense force in the nation, in any nation, keeps track of every single piece of ammunition. You want to make sure that as you push a bullet into a chamber, that bullet has always been in your possession. If it's ever mixed with any other bullet whose origin you don't know, it can explode. We do this. We leave behind ammo for the enemy to take and fire at us so that it actually explodes on them. So this is crucial. And so it's trivial for somebody within your own infrastructure to tamper with the data and to leave you with some record, with some state where you think that this thing has always been in your possession. But what they really did is they cut some records from the record and are misleading you.
The thing is that we rely more and more on digitized databases, whether it is a matter of financial transactions, administrative records, or regulated goods. But digitized databases are usually controlled by private entities, and they may be forged or hacked.
Databases are fragile. Databases that only record the current state of the world, which is the default database situation that we have, are incredibly, incredibly dangerous. So blockchains allow both parties to have reassurance on a common shared prefix of history of the world.
Now, it's important to stress the fact that the blockchain technology is still very young, and there's probably a lot more to come.
So overall, where are we with blockchains? So I think we're at the beginning of a very exciting journey, and we're just in the early days. So the entire concept of blockchains and cryptocurrencies came to be with the appearance of Bitcoin on the scene. There was much work before it, lots and lots of academic work that built into them. That's all true, but they really came onto public consciousness then. And true, it's been 9 years, and in that 9 years, we've covered a lot of ground and lots of exciting applications and different visions have been developed. But we're just beginning to understand the impact of chains and ordering and even smart contracts on business processes right now.
In fact, Professor Sirer believes that blockchain may be one of the greatest game changers in history.
Looking back, we can see that one of the main things that changed the face of civilization on Earth was written laws that completely transformed how societies conduct their affairs. Another big high point was corporations, so virtual entities that have their own responsibility and their own rights, that shield the people in them from liabilities and allow them to work towards a common goal. This really transformed society. It allowed certain civilizations to leapfrog ahead of others. And in that vein, what we're seeing with smart contracts is this ability to write executable code, preordained, deterministic, and completely independent of human meddling, executing and directing in money flows. This is a fascinating concept. Its ramifications I'm not even sure of. But I know that they're significant because I can disintermediate many kinds of business processes. Lots and lots of businesses are essentially middlemen. They connect people from one end to another set of people on another end. And in doing so, they carry risks of the middlemen misbehaving. And it's trivial to take that middleman out. It's trivial to write contracts that will take money in, divide it according to a preset schedule, and then send it out accordingly. It's similarly trivial to devise voting mechanisms that are insurmountable, that they will actually always work and the following people will have the following rights, and it's ordained in the equivalent of stone, if you will, but on a blockchain. And every participant can then have full confidence in how this process will work forever after. And this really will transform society, I believe. It's going to change the way we view businesses. It's going to change the way we demand transparency from businesses. And it's going to allow us to encode new, exciting, rich policies for how we govern our lives into a blockchain and allow us to carry them out with full confidence. And what that really means remains to be seen, but I think it's going to make us all happier and will carry us into a better, more transparent future.
So after Bitcoin was invented, the idea of blockchain was abstracted away and tried to be separated from Bitcoin, and people have tried to use it for other applications.
Blockchain technology as we have it today is not entirely suitable for EMR usage.